Looks like we're live. Welcome back to Godot Academy. For those of you who are in the jam scene, the Ludum Dare or Ludum Dare game jam has just begun. Um, Ludum Dare is just a game jam that takes over the course of a long weekend, and it's a game jam where a theme is announced at the start of the jam, and then competitors have a strict timeline for they can only work on the content of their game within the jam competition. So for us doing the actual team jam, that's in about 2 days and 20 hours. Um, all of your work is intended to be done during that time. All our assets, art, music, etc., is supposed to be done during that time zone as well. So it's pretty fast paced. So you're trying to make something quick that fits the theme and get it done on time, and probably don't need to worry too much about making it perfect. Just getting it complete is more than enough. This year's, or not this year, theme. There's usually two of them a year. This competition's theme is Keep It Alive. The theme is just voted on during the course of the last month or so up until the competition, and it looks like Keep It Alive is the one that got everybody's attention. So that is the theme. Um, The purpose of this stream is kind of to do two things. First, we want to cover, at least briefly, how we came to do our GameStorming session, which is our brainstorming session for coming up with game ideas. And then have whoever's viewing this join me as I sort of figure out some of the first tasks that I'm trying to complete, which means that hopefully I'll have something that works by the end of this, and I'm pretty sure it'll be something brand new to me, so it might be a little slow, but um, the point of this is to learn how this is going to work. So um, hopefully we'll have at least something we can interact with by the end of next couple hours. So first thing we wanted to cover is I have the sort of the brainstorming session that we went through up. This is kind of the final resort of it. Results. We're using something called Jamboard. Looks like it's just done by Google. It has a few basic tools like drawing. You can add pictures to it. You can add um, little notepad, sticky notes for any sort of ideas and stuff. And the first thing that we did is we just kind of went through when this was clear, and we just added down as many ideas that we could come up with. So every person who was on the team just sort of said things out loud or added down notes themselves until we had a nice collection of notes, and then we would sort of explain our ideas, and that would usually get somebody coming across a new idea, which would then build more game ideas, and eventually we had quite a number of them. Periodically, we would just kind of review them and see what were things that we liked about it, what were things that we didn't like, and then we'd remove some of the bad ideas, uh, maybe resize the good ideas to keep them on our mind, and then make a new set of game storming ideas from that. Eventually, though, for the theme, we liked the idea of when it comes to keep alive, we wanted to keep a fire going, so keep the fire alive. So we kind of settled on that, and then we went off a lot of ideas of what that game could be. So are you somebody who has to survive in the wilderness, and if they lose their campfire, they unfortunately perish, or is it something where maybe you're having a little fun with it? It's like an arcade game, and you got to collect as many bundles as wood as possible to get a high score. So um, ultimately, though, we kind of settled on an idea that's a bit calmer than most games. It's almost not really a game to begin with, but the idea is that you're sort of in this campfire setting that we've got this picture of. That was one nice thing about this Jamboard is it kind of lets us try out some ideas. And you're trying to keep this fire in the center of the campsite alive. It's not necessarily a difficult experience. For example, we have a pile of wood over here next to the campfire, as most campsites do, but there also might be sticks and pieces of wood strewn about in this setting. So as the character, you can wander around and pick things up and toss them on the fire. But we decided to go less of a video game with this and more of a sort of a setting or uh, almost a living diorama. So we figured, okay, what if we focus strongly on this fire and the campsite and the setting around it? And it was less about can you get the wood, can you keep the fire going, and more about, hey, Enjoy your time here. Find pieces of wood, put them on the fire if you'd like. You can put a whole bunch and make a big fire. You can add them steadily if you'd like to sort of draw it out. Either way, it's more about the setting and the visuals and the environment and what we can create um, a bit more of as an art piece as opposed to a challenging game or an exciting game or anything. Um, Ludum Dare does have a lot of different games. This one here, I forget even the name of it, that are usually a little goofier. They aren't about winning or getting high scores or anything. So it's more of just what did we want to work on, and this seemed like something that was fun for us based on our schedule and what we've been working on in the past. So after drawing out a little visual of what we were looking at, and what are some of the characters, what are some of the things that are in this environment, what are the things that you can interact with, um, we also decided to, try to get a early hold on what is our art style going to look like. We were talking about cheesy little low poly PS1 games, or from there we decided, hey, what about nicer looking but older games such as Metal Gear Solid that has a fairly, as far as today's standards go, a fairly simplified look to it, but still has a very interesting look to it. And finally, we said, okay, well, hey, there's also games that are more recent, such as Kentucky Route Zero, that still have that very simple art style, but very stylized. So um, as we work on this, we'll try to see if there's something we can do that sort of fits these lines, but also is something new that takes this campfire idea along with it. So at least for the time being, the game we're working on is this keep the campfire going. Um, on this next page, we then took it further and we said, okay, we've got this keep the fire alive and we're keeping this sort of diorama in the back of our minds. We wanted to figure out what were the things that we could do. So, for example, we wanted to be able to interact with things and we wanted to be able to walk around. Your game doesn't have to be complicated to be fun. In fact, in most cases, being simpler is more effective. So we kind of separated out to just two things. You can move around this environment and you can interact with this environment. Once we had those two things down, we also listed down like what are the things that we can do to interact, such as picking up an object, such as setting down an object, or even using something um, that's around us. And then we also listed out a number of ways that you can do that, and this would be like actual ways that the user interacts with the game itself. So WASD controls, you put your hand on the keyboard, you kind of drive this character around like a tank. We had ideas of following a more point and click adventure interface where you click on a button that says use piece of wood with fire. But then we also said, hey, wouldn't it be nice if it is sort of a minimalist, simple experience that we focus on minimalist inputs as well. So we decided, okay, let's try it. Let's try making something that's a little new to us with single clicking or tapping actions. So click on somewhere on the ground, the player moves there. You click on an object, the player interacts with it. That simplifies all of our interactions to just a single button, the left click, and of course the mouse pointer. And so we eliminated all the other interfaces that we were talking about and said, let's just focus on these two things. Now, we left some of them in place like WASD controls just in case we change our mind. But once we settled on an idea, we try to go pretty quick and say, this is the idea we want to follow. So let's focus on that. The next thing we did is what are some of the things we can do with this interaction? So we want to have a dog, so you can pet the dog. There's picking up wood and throwing it on the fire, just stoking the fire, or even interacting with the tent. And what does that mean? We don't know. We'll probably come up with ideas as we're working on this, but it'd be nice to just kind of get some ideas out now so we can have an idea of where we want to go with this. The last thing we did is we kind of went through and said, what are our actors in this game? So in a simplified sense, a scene is sort of a backdrop, your environment, and then actors within that. So actors would be things who can do stuff, or you can interact with, or they interact with you, or they interact with each other. So we said, okay, what are some simple actors that we can come up with? A guy playing a guitar. He'll play music. Maybe he'll be able to have a conversation, or he'll explain some things that are going on. We want a dog. Dog's probably just going to lay there, but we'd love to be able to have the player come up and interact with the dog and pet the dog or something like that, or maybe throw it a stick. The fire is a pretty obvious one for a game or a game about keeping the fire alive. Fire can receive wood and get brighter. Fire can also burn down. And our guess is at the end of the day, when you're out of wood and the fire has died out, that would be the end of the game. We wanted a tent. We're not sure exactly what the tent's going to do. Maybe the player can go in and grab a coat for when it gets cold. Maybe they can go to bed early. Maybe there's something else going on with the tent. Once again, we're just kind of brainstorming what are these things that are going on in this game. And then more things that are more closely related to the fire. A pile of wood. You can pick up a piece of wood from the pile and throw it on the fire. Or sticks. Common activity, at least when I'm camping, is wandering around the campsite, picking up little pieces of wood like sticks or branches, pieces of bark, and tossing those in the fire too, just to kind of keep ourselves entertained and keep the fire going. And then we had an idea of, hey, wouldn't it be cool if there was like a lake that this campsite is next to? So lake is something you could interact with. You can throw things into the lake. And the question was, well, what do we throw into the lake? Well, we throw little rocks. So maybe we'll have a rock on the campsite. Player clicks on a rock, they go over and pick it up. They click on the lake, character goes over and throws that rock in the lake. So with this, we had a list of 8 actors. We kind of had some of the things that need to be done and how we're going to do them, and some of what are the objectives: petting the dog, collecting wood, stoking the fire, doing something with the tent. So with this, we were able to come up with a plan and say, okay, let's get started on making these things happen. So, for example, the member of the team who's the better artist than the rest of us said, okay, we know that these are some things that are going on. We know that we're looking for an environment like this. How about we start working on some simple art assets that we can reuse and build this environment to get started on, so we kind of get a feel of what's going on. Next, we said, okay, we got to be able to interact and walk around. Now, being able to interact isn't much use if you can't move around to get to something. So we decided that the first thing we should do is focus on getting a character that can walk around. Now, this doesn't have to be a fully modeled and animated and everything character that fits in this environment. Chances are what I'm going to be working on tonight is just getting a circle or a square or something that when you click on the ground somewhere will move to that spot. It'd be great if we can have it move around things, because that'll allow me to map out an environment like this. And if something, as long as we can move around and interact with it, then that gets us in pretty good shape to know, hey, we can start adding these other elements on top of that. But it's hard to add those other elements without having this first one. That being said, we could always come up with something that can be interacted with, but it's hard to get the full experience without getting both of them. So after we divvied up the kind of work that we were going to do, what we do next is get started on this. So I have done a little bit of work. Of course, we did the brainstorming ahead of time as well. So there was a lot going on here. It wasn't just these pictures. There were a lot of different notes and drawings and everything else. But the next thing we got to do is actually get started on the project. So up until now, this has been pretty agnostic as far as what kind of an engine you're working on and what kind of a workflow you're doing. But since this is Godot Academy and Godot is my preferred engine of choice for these kind of projects, we're going to get started on getting our Godot project set up for this Ludum Dare number 46. Now I've already done that to save some time. And what I have is I've got a folder in here. Wrong one. Let me bring it up. LD46. I've got an LD46 folder, and although the nature of how you're going to structure your project is up to you, I typically like to do it in this way. I like to have, and I use Git, and I can cover that shortly briefly, but I like to have 2 major things. One is a builds folder, which is where you'd put the builds of your project. And the next one is a project folder, which is where your actual Godot project will live. I'm not going to cover the specifics of how a Godot project works and all of that, but you don't necessarily have to follow it this way. But I also have, for example, my git ignore that tells me what are some things that we need to ignore to get this show on the road. So to create this sample project is all I did was brought up the Godot engine. I'm using the standard version on Steam, which is currently 3.2.1 stable official. And you just select new project. I pointed it towards this project folder, and I hit new and named it LD46. Now from there, in most cases, you'd be able to just immediately get to work. But since I am collaborating with other people on my team, I want to make sure that I don't accidentally step on their toes or cause unnecessary conflicts. So since I have all of this project hosted on GitHub, what I'm going to do next is I'm just going to create a new branch. I'm using SourceTree to do that, but you can use the command line or any other tool that you'd like. And then I will create a new branch called, let's just do feature nav mesh walking. And I'll create that branch. So now I have a new branch that I can work on, I can push my changes to, and I won't have to worry about damaging anybody else's work. So from that, what I would do is just hop in and get started, but I want to take a step back and say, what is it exactly that I'm trying to work on? It's good to have an idea of what you're doing next before you jump in. That way you can sort of gauge where you should be focusing your attention and kind of not get lost in the, there's a wide number of things that we can work on. We want to focus on just the important ones. So like I mentioned before, we want to create something that is a three-dimensional field that we're projected into, and then we can click on spaces in the field and have our character here just move to them. Now, fortunately, a lot of that is already taken care of in the engine, and most engines have this as well. So we're going to use something called a navigation mesh. I don't know the specifics of a navigation mesh, but fortunately, Godot has a built-in nav mesh demo, for example here. And we're just going to boot that up really quick and take a look at what's going on. So I have the editor open. Should be able to see it. So we're going to run this project real quick. And once it fires up, let's bring the window in. We can see that this pretty much is what we're looking for. We can click somewhere. It takes the mouse location and marks that as a point. And then it comes up with the shortest possible path to approach it. And then the character moves along that path to reach their destination. So this is already pretty good news. We can always move the character around pretty quickly. It'll automatically update where it's going and meet up to it. So this is almost exactly what we're looking for, which is really good news as far as getting this done. Remember, we're making a game jam in a short amount of time. We're not trying to reinvent the wheel here. So I'm going to leave this project up on another monitor so you won't be able to see it, and I'm going to go back into my specific project here. I'll let this load for a second. All right. So we currently have our empty project. It has literally nothing in it. The first thing you're going to want to do is create a new folder, and we'll just call it test scenes. You want to make sure that you have your own test environment to make changes to, so that way when you're collaborating, you don't accidentally break somebody else's test environment. And you don't want to be doing tests on the actual scene, the final scene. What you want to be doing is working in your own little safe environment on your own scene. And then from there, you'll be able to merge it into the main scene. But hopefully you'll be more careful when you do that so you don't accidentally overwrite somebody else's work. So from here, I'm going to make a new scene, and I'm just going to call it navigation test. All right, so we have our new empty scene. Oh, and then we'll make it a 3D scene. We'll save it, and here we have our new saved file. It's relatively empty, but what we want to do is we want to take a look at what's going on in the demo scene and just kind of see how it's structured. So looking over here on this left side, we'll see that we have our node tree. We have a spatial, which designates the entirety of the scene. Looks like everything's hosted underneath of it, including the light source, including the character, including the nav mesh. We have an animation player. We'll see more about that later. We have a directional light. That's just give us a light. We have an environment. That's just to give us a behavior for the environment. Drawing. I imagine this draw is where the line is drawn from. We'll probably want to reuse that for debugging. Looks like we have a little particle engine for the floating robot. So not necessarily important for us right now, but it's good to know that it's there. But the important one is we have this level and we have this nav mesh. It looks like this nav mesh and this level are both relatively straightforward. But the nav mesh is effectively just a mesh that is applied on top of, and in fact, a little bit above the base mesh. And that is the mesh that we use for navigation. I imagine it's above just so that the character doesn't clip into the mesh as they move around it. And also it's so when we draw the line on this mesh, it's not colliding with the mesh underneath of it. It's just drawn above it so it's easier to see. All right, so let's go back to our game here, and we'll just leave this spatial here. Let me see what kind of type this is. It's a navigation object. So let's add a new navigation object here. Now, whenever you're working on something like this, it's best to also bring up the associated documentation. So what we're going to do is we're going to go Godot navigation mesh. Let's just go Godot navigation. Here we go. Oh, that's a Reddit post. Let's just go to the Godot engine. Go to, we got navigation. All right, here's a mesh-based navigation and pathfinding node. So we'll just briefly read over these details, but it looks like what we're going to be doing is giving a collection of navigation meshes, and then it'll be able to perform navigation on the fly based with those navigation meshes. So let's just experiment by saying, okay, based on just what I'm seeing with the existing project, it has a level mesh. So let's just do the same thing. Mesh. We'll just call it a mesh instance, looks like. We'll call this level. And we'll give it a very simple mesh. We'll give it a plain mesh. We can expand that plain mesh by going here, adding the size just be, I don't know, 10 by 10. Very good. And then we want to add a navigation mesh on top of that. So it looks like it's taking a navigation mesh here. What's the warning? Must be set or created for this node to work. So the nav mesh, we got to make a new nav mesh. And let's take a look at what it's doing here. So here we've got a navigation mesh. It has a couple properties. It uses mesh instances using nav mesh children. And I don't think any of these are going to be super important right now. We also know that it has a path here to navmesh.scene. So we're in this navmesh scene. So I think that's okay. So what we're going to do then is look at these as well. So in our geometry mesh instance, in our resource, it shouldn't be a problem. Let's see if we actually see the navigation mesh on top of it. We have nothing quite yet. Let's take a look here. If I move this guy around, we can see that it is a mesh that's offset. Watershed, geometry. Nope. Let me just look. All right, so we can assign verts for polygon. All right, so let's go back here. Looks like it's all using standard setup. Resource here. Okay. So according to this, it looks like it's pretty much the same as what we've got there. So I'm curious if we have to go in this some more. Nav mesh enabled. We'll give it a transform of just a little bit, 0.045, so slightly above the existing. And as far as I can tell, that's set up the way we need. So maybe we'll come back to that in a second. Let's look at the level itself. So we have a mesh. Don't need to do anything crazy with the mesh. So we can find there. No skin. Skeleton is the spatial. Name navigation. Let's see what happens if we run this, if we get a bug or something. Let's select this as our main scene. And that's right, we don't have a camera. So let's add a camera to this. It looks like we can just use a camera built into this. So let's do that. Add child node camera. And let's just preview this camera. We'll just draw it back a little bit. We're not worried about getting our camera perfectly set up either. We're just trying to get something that works, and we can worry about making an actual scene later. But that looks pretty good to me. All right, and let's also do ourselves a favor, and we'll add another point. Sorry. A kind of object are you? Oh yeah, sorry, position. So we'll just have a point in space that we'll temporarily use as our character later, and we'll give it a mesh, very simple mesh of let's do a capsule. We'll rotate that capsule up. There we now have a nice vertical capsule, and we can also go ahead and shrink it. Make the radius smaller. There we go. Let's do 0.25. There, really small capsule. So as we move this position around, which represents our little character, the capsule will follow. All right, the last thing is we need to come up with a script that controls all of this. So let's go back and review the existing script. All right, so here's the script that's attached to the entire navigation object here called spatial. Yeah, that looks good. So review the script. Extends navigation. We have a speed, that's the speed of our character. We have a camera rotation, which I don't think we even need. Or maybe there's oh that's right, we rotate the camera with the middle mouse button. So that's how we're able to rotate the camera around. So it looks like everything's sort of controlled with this one script. We also have a beginning and ending vector, which I believe is going to be our beginning and ending points for navigation. And then we have a path, and whether we should draw that path, that'll be the path that is shown, the little white line on the character as it moves around on the map. All right, so when we look at our ready statement, looks like it's doing, excuse me, a few things. First, it's telling to process every frame. It's very typical. Then it looks like it has the spatial material that we use for the material. We tell it to be unshaded, to use a point size, and then to use a color of white. So nothing crazy going on there. Now, when we go to the process, we can see that first it checks to see if there's a path. Otherwise, it stops doing anything. So every time it has a path, it processes until the path has been completed. And then once it is finished processing that path, it tells itself to not do anything. Oh, we're setting the process input there, sorry. So if there's nothing left on the path, that means that there's no point in churning over this process function over and over again. So it won't be processing until we get a brand new path to run. And we can see that here later down in the function, where when we get a new path, we then tell it to start processing. And then if we draw the path, we draw that new path as well. And that's just so that it's only processing when the user clicks. Otherwise, it stops processing. Not necessary, in my opinion, just because there's not a whole lot going on when it is processing. It's just doing an if-else statement, which is fairly cheap. But in practice, if that's that might be something worth considering, is only being processing when active, and then deactivate until there's an event that occurs that allows it to keep moving. We'll review the actual drawing of the path later, but the more interesting thing here is input. So this is the general input. This is fired off because set input is set to true. And we can see that if it's a mouse input button, such as a left click right here, and if it's pressed, so only when you press down, not when you release or when you drag or anything like that, then, let me expand this so we can see a little more. There we go. Then we get the from point, which is we take a camera, which is the camera that the user is viewing through when they click, and then we project a ray through the point that the user has clicked on to get a from vector. Then that is effectively the spot, where they've begun their click. Then to get the target, we take the from vector, which is where it is in the camera, and then we send out a projection, which is going to be a line ray that is normal to that, and we extend it by 100 units. That's just saying let's send a long enough line that it'll probably shoot through the geometry and collide with something. And then we run a function called get closest point to segment, which I believe, let's take a look at that. Takes a start vector and end vector and uses collision. And then it returns a navigation point, so this is something specific to the navigation node. And it says, give me a point that's closest to the given line segment that you shoot. If it's using collision, it only considers the intersection points between segment and navigation meshes. So I don't think we even use that here. So we don't use collision. So we're just saying, hey, navigation, get me a point that most appropriately represents the line that we just shot that's closest to the from vector. So it starts at the from, which is up at the camera, shoots through down into the mesh, and it says starting at this from point, go down until you collide with the mesh, and then use that as our desired point. So if we're looking at this, this is our camera. If I click here, it shoots a line from the camera, but it collides with this first geometry. It doesn't go through and collide with the second geometry. So the navigation mesh is saying, hey, I used some physics calculations. I shot the vector or the ray through with that vector. And the first thing, the nearest thing that it collided with, according to that, is this spot here. And that's what gives us this closest point to segment. So then we get a begin point. Remember, begin is just a vector 3 as defined up here. We then get the closest point from the robot's base in relationship to the nav mesh. So then the next thing it's saying is, okay, we've already figured out that the user has clicked right here. This was the nearest spot there, but we need to figure out where to begin from. So what that does is it says, take the robot, take this little robot base, and find the point on the navigation mesh that most closely represents where that robot lives. So that's just going to be right underneath the robot. It's nothing tricky, but it is important to note that we have to calculate both the mouse clicks interaction with this navigation mesh, as well as the robot's interaction with the navigation mesh, so that both of them can find their way to and from the points on the mesh for the navigation. Once it has a beginning and end point figured out, remember the end point was where the user clicked right here, we then update the path, which we saw before, but we'll cover again. Next, we check to see if the event is a mouse motion. We then check to see if that motion is being used with a middle mouse button or a right mouse button. That just means that this event will only be valid if we hold down the middle button, which I'm doing here, or the right button, the right mouse button, which I'm doing here. So that just says when the user holds down either of these two buttons and moves the mouse, we'll get into this if clause here. And it just says, hey, let's just take the event's relative x, which is effectively how much did the mouse move relative to its previous position on the previous frame, and we'll slow it way down so you're not zipping around. This isn't like a hard science for the number. We're just saying, hey, the amount that a mouse moves is much higher than the amount it takes to rotate a camera. So let's slow it down so that way the user's not zipping around and get a more appropriate camera rotation. Then what we do is we take the camera node. So we get camera node, the base, which is where our camera is attached to. We set its rotation. And we give it a rotation of that camera rotation value, and then all the the x and z vector components are 0. So it's just rotating along that middle point in the camera base, so that the camera rotates around it. So we'll see that they're doing a pretty neat trick here. If we look at the camera base, you can see that the camera base is actually in the center. So this is the base, like the origin of where the camera is pointing to. And we'll take a look at the actual camera. We can see it's all the way up here, and it's pointing down to that base. So if we take the preview, we can see that it's pointing at that base. So we're not rotating the camera because that's a complex, that's some complicated math that's being done automatically by the engine. We're instead going to rotate the camera base. And when I rotate the camera base, because the camera is relative to that base, it is then rotating and spinning around that base node because it's a relative position. So we don't have to do any tricky math to move that camera. Instead, we're just going to spin it. This isn't necessarily relative to the game that we're working on. We won't need to spin the camera around, but it's good to know that it has a camera pointing towards an origin. And if we ever need to rotate the camera, we just rotate the origin point, this spatial node, as opposed to trying to calculate where what the matrices mathematics for rotating that camera. Okay, so that's the input, very simple, left clicks and drag clicks for the middle mouse. Let's go back to this update path. So when we're updating a path, we saw that we have this begin and end points set before we call it. And all it's going to do is it's going to find a simple path, and this is a navigation node function that says, hey, find a simple path. Oops. Get simple path from a start point to an end point, and should you optimize it, it looks like if it's optimized, then the path calculation uses the radius, height, etc., like it says here, basically the size of the object that's being moved around to consider the path. Otherwise, it ignores it. So basically what this is telling us is get us a path, and then we say, okay, let's take a path. Judging by this comment here, vector3 array is too complex to use, convert to a regular array. It looks like it gives us an array specifically of vector 3s. That can be a little tricky. We can see here it's a pool vector 3 array. Those are a little hard to work with. Since it's a very simple array that we're not going to be doing too much with, we just convert it to a regular array, which is your simple list, then inverts it. Since the path is going from the beginning to the end, although I wonder if switching these around would actually fix that. We invert the path so we can start at the beginning point until we reach the end. And then we tell ourselves, hey, let's be active again. So if we weren't active, if we had already finished the path, we deactivate ourselves. This says, hey, let's start up again. And then finally, if we're drawing the path, this is just some drawing nodes. Looks like we have a draw node. We can even see what kind of node this is. This is an immediate geometry, which means they can immediately produce geometry for you, which I think is just more of a helper node than anything. You shouldn't really rely on it in the long term. But we can take, let's go back to our script. We can take that drawing node and we can say, use a material M. M is just a basic material with a white color that's unshaded and uses a point size. We clear it, so we delete the geometry to begin with. We then say, okay, let's begin drawing some primitive points. And I don't even know what null means. Let's here. If you want a texture. So we don't want a texture. So let's begin drawing some points with no texture, which means it'll just use that white albedo color. It then adds the vertex for the beginning, adds a vertex for the end, and then stops adding vertices. And then it begins drawing a line strip. So it added 2 vertices from beginning to end. And then it says, okay, from that beginning point to that end point, let's begin drawing all those line strips, which are just going to be the little white lines that we're seeing here. Come back up. Oh, I rotated the camera, but luckily that fixed it. So it's saying draw this point first, draw that point second, and then draw the line strips, which are defined by vector 3, a list of vector 3s that say, to, from, that get us all the way to the end here. So it's just saying for every single vector in there, it says, let's draw a line by using the vertices x in this path that we've achieved. And then we start drawing. So draw the start and the end points. You can see how they're, well, they're not really that much bigger, but it's telling us here to add those 2 vertices for the start and end. And then it just adds more vertices in between those for every single line strip there. And these are just very primitive meshes, basically tiny, I'm sure unbelievably small meshes that do the work of drawing a point-sized line across our mesh. And you can even see here that the line is raised above. See how there's a gap? We can see how there's a gap there. That's because that navigation mesh is actually higher. So the points that we get from the navigation object or the node is telling us to use these points that are slightly higher than what we've got available to us. Okay, so that's sort of a brief overview of what this is doing. The last thing that's happening is in this process, we can see that if there's something remaining in the path, so the path is just an array of vector 3s, which are points in space. It says, okay, how far do we have to, how far are we walking? That's the delta, which is how long it took for the frame to show up, multiplied by the speed of the character. So it moves 4 units per second, and any number of frames can happen per second. Looks like it comes up with a watch vector, which is just the up vector. And then while the distance to walk is greater than 0, and the path, so the size of the path has at least 2 points, we'll go over that loop. But this looks like it's where it's moving it. And then we take the position and direction based on the path. And then we make sure that the direction for y is straight up. And then we create a transform. We tell the origin of the transform to look at the desired position, which is the last point in the path. Then we say, hey, transform, start looking at from the at position to the direction position and make sure you're pointing up. So rotate across along the upwards y vector. And then it just tells the robot to use that transform. So that's just saying move to this location, spin the desired direction, and go from there. Finally, if the path has less than 2 nodes, there's really nowhere left for it to go. So we just clear out the path and say stop processing. Now this loop is one I'm not super familiar with. Unfortunately, there's no comments in this code, so it's not very useful. But it looks like we take a from point, which is the last point in the path. We take a to point, which is the second to last area in the path. We normalize those, so we subtract from the both of them and normalize it, so that gives us the direction that we want to face, which was up, but now we move it to a specific direction just in case. Then we get the distance from the from point to the to point. So how far is it? If that distance is less than the distance we have to walk, so we don't want the character to overshoot the distance. So if the character will move farther than that by the end of this frame, we then remove that point from the end, and we move the walk back a little bit of distance since we don't want to overshoot and be a little jumpy. Otherwise, if the distance is not, if the distance between them is not less than the distance that we're trying to walk, then we just take the last point and do a linear interpolation. So we go from the to point to the walk point, go from the from to the to, and a distance that is the amount that we have left to walk versus the distance to them. So not a great explanation, but basically what this is doing is this is moving our character around. This is telling the character to use that new movement as well as look at the desired point, and then applies that to the robot. And then finally, if it's out of room, it stops processing. So little bit off topic from working on this game, but it's important for us to know how this nav mesh works on a high level so that we can go ahead and re-implement it on ours. So let's come back here. Now I wish this would show our navigation mesh. It might be because I need to, let's change this to match navigation. And then let's just move the level here. Let's get rid of this guy. Yep. Now we have a position here. We can just move this, say it's character. We can take our mesh instance, which is just the character mesh instance. We don't even need to worry about that. And then finally we have our level, which is currently a very boring mesh. And then we have a navigation mesh that uses that parent, I believe, to figure out. So really there isn't much to navigate on this. This is a single mesh, so it's not particularly entertaining. But we'll add a script to this, and we'll just make it a built-in script, so we don't have to create a new file for it right now, since this is just going to be a test script. So we're going to go line by line and sort of rewrite the script according to us. It's going to be pretty close to what's going on, but I might change some of the names around so it's easier to read, because I'm going to be using this later. And we're going to say player walking speed. And we'll do const speed equals, and we'll just use the same value because we know it works, but we'll tweak it later. All right, and then we'll do, we won't worry about camera rotation actually, because the camera should be static, or if it is going to move, it's going to be dependent on other variables other than the player trying to move the camera. So the player won't actually have any control over the camera, since it is sort of a static little diorama. Next, we're going to define our movement, our navigation points. So we'll do var begin, or navigation begin, which is simply just a vector 3. And we won't put any parameters because it's just basically an empty vector for now. Our navigation end equals another vector 3. Here we go. And then this will be our, let's make a material for the line to draw. So line drawing material. And that'll be var m line material equals spatial material. And we'll just make a new one. Now we have to use .new because this is a resource, whereas vector 3 is just more of a more basic type. You can read the documentation as to why you use a vector 3 directly as opposed to using new for material. You can see that slightly different green colors, but in general, it kind of takes practice to know when to use new. Materials, I just know, are a resource, so you have to instantiate them a specific way. All right, or maybe more accurately a node or something, but we won't worry about that. All right, delete this. Finally, we need the navigation path. And so we'll do var path equals an empty array, and draw path equals true because we're debugging this. Eventually, though, we'll probably turn that off since we don't want the player to actually see that line as they're playing the little game. So first thing we'll do is process user input. So set process true. I set process input, sorry, to true. And then set up the mesh for the line. So once again, I'm just copying what we've got over in the demo project, but we have line material, and by mesh I mean material. Look at that. Material. And line material dot filter or flags, sorry, flags unshaded. This says don't use any fancy shading with it. Basically, it won't be affected by any light or anything, which makes it, you know, a clean sort of UI line for debugging. Line material dot flags use point size equals true. And then the most important one is line material dot albedo color equals, now you can do color dot anything, but let's do something, let's use antique white. That'll be a little more interesting than just plain old white. And that's all for our ready function. So not anything crazy being set up here. Later, once we have a full scene, we'll do more than that. But what we'll want to do is make sure that we reorganize our scripts in a way that better accommodates how the full scene is going to be generated. So I probably wouldn't have a spatial here. I would probably organize the navigation mesh in the scene in a more appropriate way so that the whole scene is not fighting over all these scripts. It'll be organized in inherited scenes that we import into the scene. All right. So the next thing is the process function typically, but before I do that, I want to handle the input because that's the most interesting one for me. So I'll make a new function for input. This is the input function that gets called when set process is true, and any input that happens into the game will be received here. What we would ultimately do is, instead of using general input, I'd move to an input event later in the project, but since I just want to get this example working in our project, I'm going to try to mimic it as similar as possible. So we want to pull for left click input. So if event is input event mouse button, which is the event for any mouse button, as you can guess, and the event.button index. Oh, that is input event mouse button, and button index is button left. That's just sort of a built-in constant to the engine that says this is the index that a button left click will always have, so we can check that against the event. And finally, we want to make sure that the event is pressed. So if all of those things are true, and let's shrink this so we can read it, we know that we've been left clicked on. So we're just going to do a couple very simple things. We'll grab the starting point for the click at the camera itself. So var from point equals get node the camera dot, and then it'll project ray origin. It says project ray from the origin of the camera, which is a single point in space. We can kind of visualize this here, but if we look at the camera, we can see that, oh, why isn't the camera showing itself? Usually it shows the camera. Why did it do that? There we go. So this here is the origin of the camera. You can see it's just a tiny little point where this camera is that all of these focal points come to. When we want to figure out the camera's projection, you can think of this square here, or maybe it'd be easier here. This square here, which is in front of that point, this square here is what the user sees. Now, effectively, that's going to be a projection of the actual scene onto that that little, whatever you want to call it, a little square there. So when we're trying to calculate where the user clicked here, we've got to project from this point here to the square here to figure out where exactly they pressed. So to do that, we just project array origin, and we do it to the events dot position. Since it is a mouse left click event, it has a position, and that's just saying when I'm here and I click, let's say I click preview on this camera. When I click here, then what's happening is it shoots a ray from the center point to the point on the camera that I would have clicked at. So that was kind of in the top left corner area. And it figures out where is that point in 3D space in this scene. Next thing we want to do is figure out the 2 point. So var 2 point. Now we're going to do the same thing. We're going to get the camera. This isn't the most effective way to do it, so we'll probably be more efficient later. But this is a game jam, so who really cares? And then we're going to project array normal. Project ray normal. Oh, that's local ray normal. Project ray normal. There. And we say, okay, let's project array normal from a screen point. So that's going to be a point on the screen, which once again is the event's position. And we're going to extend that ray 100 units. Once again, we're just copying what the thing was doing. This is just something that's long enough to shoot out. So if we were to project something from this event position here and shoot it out onto this mesh, if you were to draw that line, I mean, it might start at the camera here, shoot through, hit the mesh there, and then press through if it was a line. I mean, I don't know the best way to visualize this else in here, but it's just shooting a very long line straight from here. So now that we have the from and the 2 points, we've got that ray projected all the way out. We now have a start point and an end point. So we want to say, hey, navigation mesh, let's find a point that most closely interacts with that ray from the starting point to the end point. So we'll do var mesh point equals, and then we're just going to call get closest point to segment. That segment is going to be a start point and an end point. So once again, that is going to be the from point, the 2 point. And I forgot one crucial thing. We got to make sure that the 2 point starts from the from point and moves out. So we'll adjust it from point. Sorry, from point plus. So more specifically, we're saying start from here. So offset based on this origin over to the screen where it renders the screen at, and then project your ray. Otherwise, it would project the ray from the center straight out, but we want to adjust it so it has the same starting position when it projects that ray. So we now have a point on the mesh that we want to navigate towards. So very simply, we can then set our navigation begin as our get. We want to get the closest point to the player. So we'll just do get node of character. So if I get the character's node, get its translation, get translation, so find the closest point on the navigation mesh to that character. And then finally, we want to find the endpoint, which we'd already found here. So honestly, what we could probably do is change this to navigation end. Navigation end equals this one. So it says find the starting point, which is just wherever the character happens to be at. Find the endpoint, which is where that that segment that we launched. We want to find out the point that most closely represents the segment's collision with the mesh. And then finally, we're going to update the path that we're looking at. So we don't have it defined yet. Let's just do func update. We'll do it underscores because it's kind of a private function. We don't need everybody being able to call it, even though they still can, but it's good practice. Update path. And we'll pass just for now. So we will call update path. And that is our input. In the example, they also handle camera movement, but we're not going to have that standard camera movement in the game, so there's no point in implementing that for now. So let's do the next thing. Since we already have this update path being called, let's add that path. Very simple. We're going to use the navigation to do most of the hard work. So we want to first get the path out of this navigation. So var path equals get simple path. Let me just change this. We already have var defined, var path defined, so let's just merge this into one. So we're getting a simple path. The path takes the navigation begin point, takes the navigation end point, and the last parameter for optimizing is default to true. We'll just make sure of it, mostly just so we can explain to ourselves later that yes, we do want to use optimization. As far as what the code's doing, it's identical. But sometimes it can be more useful to be explicit about what you're doing instead of implicit, so we know that yes, we do want that optimization. But we have this path, and remember it was a complex vector pool array of vector 3's, which are a little hard to use, and it's mostly for very large arrays, but we don't need a very large array. It's a very simple mesh. It's going to be a very simple mesh in the end scene. So we'll just take an array, array, and we'll cast this pool 3 vector array into a regular array. What's going on under the hood, don't worry about it. But it's going to take that more complicated array into a simple array. Might be more memory intensive, might be more computationally intensive, but it's a very simple navigation mesh for a very simple game. It doesn't have to be precise. Now that we have this array, we want to invert it because the path is actually backwards. I don't know the specifics of that, but that's what it's doing, so we'll copy it. So path.invert, that just inverts the array. And then finally, because we have a new path, we're going to set process to true, because now is when we actually start moving the character around. Finally, in this update path, whenever they click, remember we don't have to redraw the path every single frame. We just want to redraw the path once whenever the player clicks. So we're kind of doing an event-based draw. So let's just draw it ourselves. So draw the path that we are navigating. So if draw path, very simple. So we're going to get the, actually we need to add something. So to draw the path, we're going to use that immediate geometry. So very powerful. It's good to know more about it. We're going to leave it at the origin. I don't know if it even cares where its origin is at, but I assume that since everything else in the scene is based on the origin in the scene, it's best to keep it there as well. So because we have a path, which is a bunch of spaces on this navigation mesh that are appropriate for the for this mesh in particular, we will then, oh, there's the script. We'll then, okay, well, let's grab the line draw equals get node. We'll just leave it as immediate geometry. You could always call it line later, but once again, it's for debug purposes anyways. And then we'll do line draw. We'll set its material override. Now, what we could do later is actually define a material in the editor, have that as a dedicated resource instead of setting this material and instantiating it every time on runtime. But once again, it's really not that difficult for the engine to produce this material, let alone is it not that complicated for, it's not very resource intensive for it to assign that material. So it's nothing to really worry about when we set this material override over and over again. Like I said, there's bigger fish to fry as far as what we should focus on. So we're going to set material override. Oops. Material override. There we go, with the line material that we set up before. So basically a off-white line. Then we're going to clear whatever it has currently, because we don't want to keep stacking lines on top of it. It might be fun to actually see how it looks without clearing it. In fact, let's just do that just as a fun experiment. So we're back to the original. Let's comment out this clearing function and run it. And we can see here how every time I click, it doesn't clear out the line. So we can actually sort of see how it alters the line over time as opposed to clearing it out every single time. So let's just do this fun drawing, but it's really not that useful unless you really need it for something, and we don't. So that's why we got to clear it out. Next, we're going to begin drawing the line vertices. So we're going to start with the primitive points that signal the beginning and the end. So line draw dot begin. We're going to say begin starting with mesh dot primitive points. There we go. In fact, we might be able to try something else to see what happens. And then we're going to do draw dot add vertex. We're going to give it the begin vertex. We're going to give it the end vertex. This will be navigation begin and navigation end. And finally, we're going to, since we're done with this primitive points, we just wanted the start and end points. We'll do line draw dot end. That stops drawing those. And we're going to switch to a new shape, which is just the primitive line strip. So begin drawing the line itself. So line draw, we'll just do line draw dot begin. Mesh, once again, has all the things. We'll do primitive lines. If you did like a line loop, that would be a line that always loops back to the start. I imagine we get a pretty noisy line if we did that. Line strip, I think, is just individual line strips instead of a consistent one, but we'll see. We can play around with that as well to see what comes up. Oops. But we'll just draw the primitive lines on this one for now. And then we're going to go over each point, the path. So for point in path. And we're just going to add a vertex for it. Add a vertex to the line. So line draw dot add vertex. And it's just going to be that point in the path. Very simple. And then once we're done with the path, we no longer need to draw the line anymore. So we'll do line draw dot end just so that we're done with that. So with this, we have a few things set up just right now. We have the material, that's fine. We process input, that's great. Then we pull for the left click event. Finally, we get the point drawn from the camera to the navigation mesh, find that point, and then use the point closest to the character, and then update the path according to those 2 points. And then the path is just getting the path from the navigation mesh, inverting it, telling us we need to start processing, and then drawing that path. So let's see what happens just from this. nothing is happening. So I think there's something wrong with the way that I have the mesh set up. That might take some investigation that I'll do in a bit. But just to experiment, we have primitive points here. If we do primitive triangles, let's see what we get when we play this thing around. Looks like it's probably doesn't even matter, to be honest, because it's drawing just a single vertex. Let's just try something else. Primitive triangles for this one, and redo it. Okay, so here it's trying to draw some triangles. So what it's saying is, because these triangles are relatively small, or these paths on the navigation are relatively small, what it's doing is it's drawing a triangle based on the last 3 points. So it kind of comes up with these weird triangle shapes that are hard to see. But if you do a really long movement, we can see that it draws a bunch of triangles as it moves around from the top down, and then a big triangle as the character tries to move up the hill. So it's just a way that it handles drawing triangles, which I'm sure you can learn about in the documentation, but it's not very useful to us right now. I'm going to try one thing and remove these guys. I'm curious what we see here. And it looks like it's about the same thing. Let's move this to line loop. Let's see what that looks like. Yeah, that's what I thought it would. So it looks like those initial 2 vertices don't even do anything, which is what I suspected. But by having a loop, we can see that when it reaches the end of the path, it then draws a final line back to the start. So those are just sort of the things you can do with the immediate geometry. Anyway, that's enough messing around. We need to figure out why our navigation mesh, for whatever reason, does not want to take on the shape of the actual level. So to do that, I'm going to bring up the existing demo and just see what I'm missing. It might just be because I'm using sort of a, this isn't good, sort of a baked in mesh as opposed to a fancier one here. So let's see what's going on. In the level, we have this mesh. I'm assuming this was imported in and is baked into the scene as a skeleton of types of that spatial. And then we have the navigation mesh. So if we come back and we go to our mesh here, skeleton is the spatial at the top. I'm looking at both on the other screen. As far as I can tell, it's mostly the same. I mean, this is just a mesh, so there shouldn't be anything particular in it. I'm more concerned about this navigation mesh, but it also doesn't point to anything in particular. It's the script to it, that's about it. And then the nav mesh itself, let's take a look. When we look at the nav mesh, and I've got it up over here, it's type navigation. We'll just take a look at everything all at once. So, sample partition type watershed, that's the same. Geometry mesh instance. Source geometry is nav mesh children. I'm curious why it's that. But it appears to match. The cell, those are the same sizes of the cell. The agent has the same height, radius, climbing ability, and slope. The region, same region size. The edge, same edge size. Polygons is 6, I believe. Details, the same 6 and 1. Filter, all the same. And resource, the only real difference is that the resource path is different, but that's expected. And it's enabled. Yeah, let me take a look. What's going on let's suppose I took this nav mesh and I added a new nav mesh to the existing one. And it needs, specifically a navigation mesh resource must be set or created for this node to work. All right. I don't know where that navigation mesh instance is even coming from. This could be something that they baked in by hand somewhere else, and it's not actually part of the project. Oh, no, maybe it's because I'm foolish. All right, so one thing I forgot to notice here is here at the top, we have a few toolbar items. It's probably painfully obvious to somebody, but what we can do is we can bake the nav mesh. So when we click on this, it should bake in a nav mesh to, maybe not, 0.045, let's do that. If we bake in the nav mesh, bake it in, and then we hide the old one. The new one still doesn't show, so maybe that isn't quite so helpful. Okay, I see what I did wrong. We'll delete this navigation mesh. We're going to start from the mesh itself. So the mesh itself has a few options. And we're just going to create a navigation mesh that adds a child. The navigation mesh should be that child. And we can see that that's matching there. So the problem was that our mesh that we created was empty. That's because we created it by hand by adding the node ourselves. It's would have been smarter if I thought of it to use the built-in tools to the engine. That's what makes Godot so powerful. And give it a navigation mesh that it itself is, it's going to make the correct mesh for this navigation. So let's run this guy again. Here we go. And now we have our line. So once again, it's very simple. All it's doing is drawing a line from our character onto the point that we click, and that's because our mesh itself is just a single square. You can see that when we point off and click, it's still using the navigation mesh to find the closest point, and that's just because the navigation mesh is trying its best to find the closest point. So what's happening is that line is shooting out 100 units from the camera, and it says, okay, what is the point that is closest to that line 100 units away? Oh, it's this one right here. So you know, it's not that important unless you have a game that you happen to be clicking off the screen a lot, but it's just important to know that it's going to be doing its best to find that perfect point. So the only thing that's missing from our script is the movement of the character. So once again, we're going to kind of base this quite strongly on the existing navigation mesh. So the first thing is we want the function for processing. Once again, the delta is the delta between frames. So because the frame time can be different, and usually there's very many frames per second, just using a single speed means that the character will move faster or slower depending on how long it takes for the frame to process. So we use delta to adjust that speed to make sure that we don't run off the edge. So once again, we're going to see, is there anything left of the path? So if path.size is greater than 1, then we're going to do stuff, but otherwise nothing left to do until the next point is clicked. And we'll just do set process to false. So we'll just wait until the next click event happens, which is in this event, this input event handler there. Finally, now we're going to do distance to walk is var to walk distance equals delta times the speed. So 4 units divided by how long, 4 units per second divided by how many seconds it took for the frame to process. If you're running at 60 frames per second, you don't want to move 4 times 60 units per second. You want to move 4 units across those 60 frames, because otherwise you'd fly out of the screen really quick. All right. Now, oops. We're going to do direction to look. Looking for now, we're just going to do a plain old straight up vector. So our look direction equals vector 3 and just the up vector. So by default, if nothing happened and we applied this look vector to the character, it would just stand straight up. It's your equivalent of T-posing, I suppose. Now we're going to say, while we still have a distance left to walk, so while walk distance is greater than 0, and there's at least 2 points on the path, so somewhere to start, somewhere to end left on the path, then we want to make sure that we have to at least have distance that we're traveling and a place to travel from and a place to travel to. So and path dot size is greater than 2, so a start and an endpoint. There we go. Where to start on this segment of the path. So where we're starting, very simple. Our path start equals the last element in the path. So let's just do it this way. Var last step equals path dot size minus 1, and var second last step equals path dot size but minus 2. So the starting point is just going to be the last step. The var path end equals the second to last step. There we go. Now we want to figure out the direction that we're facing. So that typically when you're moving forward, you're going to be looking the direction that you're facing, that you're moving. We're not going to have the character walking backwards or sidestepping or anything like that. So the character is just going to look the direction it wants to walk. Very simply for now, maybe later we'll have turning and weird animations like that. But for now, we're just going to do very simple, go the direction you're facing, turn, go the direction you're facing. So what direction are we walking? So we want to update that look direction, which was just a straight up one to say rotate that look direction to match the direction that we're moving to. So we're just going to take the path end, subtract the path start, and then we're going to normalize it. So basically we're going to take the vector from the endpoint to the start point and then normalize it. So it's just a single unit, regardless of how far away the points are, you're still only going to look one direction. So you can't really look further one direction or less far in one direction. You're just going to look that direction. So we normalize it to get basically a one value pointing in a certain direction. I'm not the expert on teaching vector mathematics, so just think of it as you're taking a thing of static length, for example, this Leatherman, and you're just rotating it in the direction it needs to go. So if we want to move that way, we're going to figure out what direction to face that we're moving that same direction. All right, now we want to figure out what is the distance that we have left to walk. So how far left to walk on this segment? So we want to figure out the from and the to. So the full distance, all right, let me rephrase this. What is the distance of this segment? So of the segment from the start point to the end point, regardless of where the player is currently at, we want to figure out what is the distance of that segment. So our segment distance, or length even, is just the from point, so path start, and very simply it has a distance to the path end. So that just says what is the a scalar value, what is the value that is the distance between the two of them. We can even see, apparently the docs aren't there for that one. If the distance that we're going to move, the walk distance, is somehow, all right, let me put it, if the distance that we're going to walk is less than the from point to the to point, excuse me, then we want to step over to the next segment. So are we going to step over the point to another segment. So if walk distance is less than, or are we, let me rephrase this, not moving so fast we skip the segment. So if you happen to take a really big leap, we want to jump to the next point, just so that you're not sort of stuck on one point. Typically, if you're moving fast enough, you shouldn't take a step that's larger than a point, but it's good to accommodate for that just in case. So if we happen to move farther, that is the distance of the segment that we're currently walking, we want to make sure that we can handle that. But in most cases, you're not going to move that fast. So if we're not moving so fast that we're farther than, oh, sorry, I think I've got it all backwards. I apologize. Segment length. So if the length of the segment that we're walking is less than or equal to, let me rephrase this, I had it right in the first place. Are we stepping so far we skip the segment? So if the segment itself is smaller than or equal to the distance, so walk distance, then we need to shorten the walk distance and move to the next segment. So we're basically saying, okay, you took a pretty big step. Maybe I can draw this guy up for you. Let's do, whoops. I gotta fix something on the GitHub later. Okay, let's do a notepad, or not notepad, paint. Let's do simple paint. So let's suppose we're looking at a couple of points. We have a point here, and a point here, and a point here. If the distance that we're walking here in brown is very long, then we might be walking over here, across this point, and into this new segment. So what we're going to do is we're going to cut off our distance here and move our start point to this. So then instead of moving, say this was 100 units, but this distance here was only 70 units, then the remaining 30 units is what we're going to take a step on, but starting from this point. So we're only going to move 30 units as opposed to moving the full 100. If we didn't subtract that 70 distance, we'd move another 100, which might cause us to skip another one. Effectively, we'd be moving infinite amount. So we want to subtract the distance between each of these points, so that way our step size, if it happens to be very large, gets small enough that we're not stepping over the next point. If we happen to reach the end, we just say, okay, whatever distance you were going to move, we'll just freeze you at the end. But for now, we're only moving this amount. So we shorten that walk distance. 1 second, let me bring it up. Oh, I do have it up. Okay. So if we're happen to walk this far, then we say, okay, move to the next segment. So path.remove. And then we'll do path.size yet again, -1. So we're saying remove that last point. So we're moving up a step. Remember, we're moving from the end of this path to the beginning. It's a little weird to me, to be honest. I think it would be fine to do it the other way, but that's just the way that this is happening. And then finally, we're going to change the walk distance to be shorter by the length of the segment. So like I said, if the walk distance was 100 units and the segment is 70, we're going to say, okay, now we're going to start at the beginning of the next segment, but only go 30 units. All right. So then the loop goes over again, and then eventually we'll get short enough, or probably already will be short enough, that our segment length is certainly going to be longer than the step that we're taking. So if it's longer than the step that we're taking, then we just want to figure out, move the starting point to be the end of the step. So if we go back to our drawing, if this is our starting point, we have our path here, here, and here. Let me clean this up a little bit. There we go. So remember, we took this big line and we kind of cut it here, so we only have 30 units. So if we're starting here and we move 30 units here, what it does is it takes this point and moves it up to match. So now our segment is from the end of this point, this end point here, to this last one. So as we take steps, say our next step is only this long, or next one is this long, this guy also hops forward and hops forward. So now our end segment gets shorter, 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 shorter. And remember, when we happen to take a step that crosses the boundary from the end of one segment to the next, which in our example was this really big step, but since the segment on the end is shrinking, it's more likely that we'll reach that end and step onto the next segment. Then it does the same thing. This point at the end becomes our last point, and say it moved down here, like so, then it would shrink, shrink, shrink until we reach the end. So that's what we're doing here. We move that starting point, which is the end of the array. Once again, I'm a little unsure of why it's at the end, but maybe that's just for the sake of it's easier to take things off of the end of the list than it is to take things off of the front of the list. So we say, okay, the path at the end minus 1. So the index at the end of the path is now a new point that is the linear interpolation. So to explain linear interpolation, it's very simple. Say you have a point in space here, and you have a point in space here. There's a line that goes between the two. Now, there's some, you might want to do some trigonometry if you're feeling up to it. You got your right angle, you got some angles here. You can calculate the exact distance between these two and find a point along that line. That's a lot of math you don't want to do. The engine has it already calculated, so no point in you doing it yourself. So what we do is we take this line and we normalize it. So we say, okay, the point here at the end is 0, and the point here at the start is 0, and the point here at the end is now 1. We then, when you linearly interpolate, you can then say, okay, give me the point at 50%. You can just give it a point, and it says, all right, I'm going to scan the line until, do some math on the vector until we find the 50% point. Or you can find the 75% point, which might be somewhere up like this. Or you can find the 33% point. Whatever value you give, it'll give you the point along the line that matches the percentile in the normalization of that line. So 30% would get you a point here, 75% would get you a point here. In some cases, you can do 105. Say you went, let's do 110%. In some engines, I'm not sure about Godot, but I think it might even extend the line, kind of extrapolate that line out and find the point that would be past that line matching that. So it's not often that you want to jump past a line if you're linearly interpolating it, but the interpolation is nice because it gives you a normalized way to find a point along the distance of a line. So in Godot, the way we do that is we say, okay, the new point, we want to move up a percentage. So if you recall correctly, when we want to extend that point forward, let's say the step ends us here, we want the new points to be here. So if we linearly interpolate and figure out what value we need to move to get to this point, we can update the starting point to this new one. So to do that, we're just going to take the from point. So path start, which is the starting point, which is the left side. So we're going to take starting here. We're going to do a linear interpolation. And we're going to go to the 2 point, so path end. So that's saying now we've got this line here from the start to the end. And then we want to give it the percentage to access it. So if I did 0.5, that would be the middle point. If I did 1, that'd be the end. If I did 0, that'd be the start. So to calculate the distance that we're walking, we're going to start here. We're going to move along this full distance here. So remember, we know the distance from the start to the end, and we know the distance that we're trying to step. So we can just simply say, what is the distance that we're walking? So walk distance divided by the length of this segment. So segment length. And that will give us a percentage along this length that the step takes us. From the start to the end, we interpolate that and we assign it to the last point. Finally, once we've reached the last point, we say, let's just move the walk distance to 0. So that way we kick ourselves out of this, this loop. And also, we're done with that. I think it might be smarter instead to use break because we don't really want to check the condition again. Once we've reached the end of our steps, we're done doing that loop. So, oops, that doesn't do us any good. Finally, once we have, oh, sorry, I got ahead of myself. We want to do lock distance to 0 for one important reason. There's something to do after this if statement. So once we have figured out where we want to go, oh no, I was right. Let's do this. So once we've figured out the look direction and the target point that we're going to, we're just going to set the point of the character to that line. So remember we pushed this segment up, so we now have a new start point. We're going to just put the character here because we know that the very last point on the path is where the character is currently at. So we're just going to put the character here and then make it face this direction. So what we're going to do is we're going to do var character position equals path.size -1. So we're going to put it at the very last point, the one that we adjusted forward. Get the character's position on the path. And remember that we already calculated the look direction for the character. So now we're going to say make sure the direction we're facing does not adjust in the y-axis. So we don't want the character to topple over on itself. We just want it to make sure it's consistent. So look direction equals .y equals 0. So what that means is if we go back to the example, because its geometry is a bit more interesting, when we calculate a point, say going up and down the hill here, and ignore the lines, if the character was facing along this line here, they would also turn and adjust to look down. So as the character goes down a slope, they would lean to look down it. As the character goes up, they would lean the other way to go up. And that might be more realistic in a game where you have a person walking around and moving it. But since our game little thing isn't going to have any sort of we're not really going to have height, or if we do have height, we're not going to have the character like always matching the height of it. The character is going to stay relatively balanced. And in this case, we have a little floating robot, so the robot doesn't need to move up and down. It just hovers over the geometry. So we're not going to worry about having it change its rotation in the y direction. We're just going to keep it standing straight up. All right, close that guy. Back to my script. So now that we have a direction that it's facing and we have a position for it to exist, we want to apply that transformation to the character. So let's make a new transform. Character transform equals transform. Then the character transform dot origin is the place that it's at on the line. So equals character position. Finally, we're going to take the character and say, starting at the current position, make it look at a point that's in the direction that it's walking, and rotate it along the y-axis, upward axis. So we can do character transform equals the character transform. When we rotate it, it returns a new one. Character transform dot looking at the desired position, so character position, which is the start. So remember, at position we have is the, oh sorry, yeah, this character position here. It's going to be starting there, and finally it's going to be oh sorry, it's going to be starting at the desired position, but move it to the in the direction that it's moving. So that's not too much. Let's look direction. So it's going to face in the look direction. And then we're going to make sure that when we rotate it, we keep it rotated along the up axis. So it doesn't, once again, doesn't topple over. Finally, now that we have it rotated in the direction we want, we just want to apply that transform to the character. So we do get node character. we go. We'll set its transform. So set transform and give it the new transform, character transform. There we go. So now we've taken the steps to move along the path until we reach the end. So until we find this point here, we then move the character to that point and tell it to face in that direction, and then apply that transformation. So let's give it a shot. We've got our character. There it is. I think we forgot one last thing. Oh, yeah. Let me make sure that when we are done, so if path.size is less than 2, so if there isn't a start and an end, if there's only one single point remaining, which really shouldn't happen, really it only happen if we delete the last point but don't quite reach the end point somehow. Just in case, though, we set it to greater than or less than 2. Then we clear the path and we say stop processing. False. All right, so one thing I did notice is the character didn't really seem to want to move. So let's see what happened there. We're still finding the points going around. Oh, the character's halfway in the ground. That's one of it. That's because our character's origin is in the middle of the mesh. So what we can do is we want to move the character itself, its origin to be just above, but the mesh, we want to move the mesh up relative to the character. So then we see the character's origin is at the bottom of the mesh, so then the character's kind of walking on top of the land instead of getting sucked into it. Here we are. There's the character. Nothing crazy. Oh, had something there. I don't know what happened there. It did move though. I don't know why it moved in that case, but didn't move. Otherwise, it's weird. I think I typed something in wrong, so let's see. Okay, so look at our script, and let's see what we've got here. So if the path.size is greater than 1, we move according to the speed times the delta. We make sure we look up. Then if we're stepping greater than 0 and the path has some, I think that might be it. So our path is always very small. So that might also be, oh, jumping around. Let's inspect what we did here. So the last step is the path at the -1 location. The second to last step is the path at the -2 location. In fact, we don't really need those. Let's just get rid of those guys. All right. Then the look direction is the to to from, so end to start. Normalize it. The distance is the start distance to the end. Gives us a length of the segment. If the length of the segment is less than or equal the amount that we're walking, then we remove that last segment and subtract the walk distance to match. Otherwise, the path at -1 from the end becomes the start position interpolated to the end position based on the walking distance divided by the distance of the segment. This is the only thing that's really different. I don't think that'll make a change though. Equals 0. Finally, I think the issue is with the transformation. So the starting position is the path size -1. The look direction's y direction is 0. And look direction should be this guy, which we do as a vector up. transformation. The transformation's origin is the character position here. It looks as that looking at the character's position plus the direction rotated at the up vector, and then we get the character. We said it's transformed to the new character transform. The path that size is less than 2. Clear the path, set it to false. Otherwise, we set it to false by default. That looks about right, and the path looks good. I think this might be just an issue due to the closest from the character node is translation. The end point is the closest point to segment of the from point to the to point. The from point is the camera's projection. We already know that the line is good for the path. Something's wrong with the character's movement, though. Oh, well, maybe it was that breakpoint thing that was the problem. Character's moving just fine now. So let me figure out why putting break here is bad, right? If we do break, oh, I know why. So even though we're breaking out of the loop, the distance that the character has to walk needs to be adjusted to match the segment that it's walking on. So we could put break. Logically, it makes more sense because once we've reached the end, we want to say we're done walking some distance. And so we don't need to, wait, what? Oh, shoot. Okay, no, break was right. Here's the problem. Maybe this was obvious to people watching. We have this inside of the while loop. So whenever we reach the end, aka whenever we were moving within within a segment, we would then break out of the loop and we wouldn't actually update the character's position. Now that the character's positioning update is outside of the loop, now we're getting what we want. So issue with me translating it, but once again, I could have just copied all the code, but I learned a lot more typing it up by hand. And the other advantage is I can put comments in, which weren't in the original code, so that when I come back to modify this to work with the game as a whole, we've got everything that we need to go for this. So yeah, I think that's just about it for the navigation mesh. What I need to do now is make the mesh more complicated so that the player can navigate around things in the campsite. So although I don't know that I'll have too much time for it tonight, what we would do is, let's review our diagram here. We would create a navigation mesh that has a couple of holes in it. So for example, a hole for a lake, or a hole where the tent would go. We don't want the player to walk through the tent, we want them to walk around it. Or a hole where the campsite would be. Or maybe a pile of wood. You can't really walk into a pile of wood, so we don't want to allow the navigation mesh to consider that. So what we would do then is, well, let's try it in, let's fire up Blender. This isn't necessarily Godot related, but if you're interested in this, this is all part of the game development process. Let's do something simple. So we're going to add a mesh. We're going to add a plane mesh. We're going to scale it. Let's just do this big. And then we're going to, oops, we're going to, how do I get my command palette back? Hotkeys are different from what I remember. Or maybe I just don't remember it correctly. Always have your cheat sheet. All right. What is the cheat code for finding something? Rendering, selecting, camera cursor, modeling, face grade. There's got to be a subdivide. Maybe what I want to do is actually apply something to this mesh itself. Let's see, where are the, I don't want rendering stuff, I want the modifiers. Can if I decimate it, what does that give me? So what I'm trying to do is I have this plane, which is very plain, but the problem is it only has a few vertices. So as I move this around, I'm not getting, what I'm trying to do is create a sort of a interesting terrain that has a lot of spots in the mesh, so I can cut holes in the mesh, so I can sort of make adjustments to this mesh, and have sort of bumpy terrain for the character to walk on top of. This probably won't be the final mesh, but it's more of just we want to have something to start with so we can begin modifying it to work. Excuse me. So decimate is the opposite of what I want, I believe. I think a lot of these are overkill, but well, let's use the internet. Let's do Blender mesh subdivide. How to subdivide a mesh. So in edit mode, which is tab, we're going to select our mesh. We're going to do, don't want the knife, spin, smooth, edge, slide, shrink, rip. Oh, there we go, subdivide. So now we have a few more points on this. If I move this around, you can see that instead of modifying the whole half, we have kind of an area here. So what I'm going to do again is subdivide, and subdivide, and subdivide, and subdivide. And now we have a fairly complicated mesh. Let's subdivide it again 2 more times, and let's scale it up a bit so it's fairly big. So now we have a mesh. So what we can do is let's set this up side by side to our picture here. Oops. Can I zoom in on this guy? Looks like this is it. Zoom in. All right, so looking at this, we have this picture here, and let's just make something that's a little bit close. So let's see, how can I select? Lasso select is control left click. So, oh, that's not it. Control alt right click. Oh, like I said, these are old. How do I select scale, transform, annotate, measure, extrude faces? All right, select lasso. So looking at this, let's just suppose we had a lake up here. So we'll select all these and delete all of the vertices. So now we've got a hole cut out of this. I'm not an artist, this isn't going to be perfect, but it'll be close enough for what we're trying to do. Likewise, what we can do is we'll do a box select, and let's just say there's a tent right around, or we want to get our perspective right. Let's maybe move our tent to like that. Delete those vertices. So now here's a hole in the mesh where the tent would be. We would then later put a model of a tent on top of it. But for now, it's not critical. Next, let's build our little campfire spot. I mean, this is already not very close to what we need, but once again, campfire spot there. And finally, we've got a guy on a log. Let's draw our simple log like that. Delete those vertices. And maybe we've got a wood pile that we don't want to be able to walk on top of. And oh, we almost forgot, we've got a little dog laying by the tent. We'll do this. So this might not be the best way to set up a mesh like this. Ideally what we would do is we'd have individual meshes, combine those into the navigation mesh for the engine. But that's going to take a little practice, and we kind of need objects to work with first. I just want to practice seeing how this looks. Now, next thing I want to do is give the terrain a little bumpiness to it. So let's see, Blender, brush. Let's see what I can do about that. Creating terrain. So we want to use the sculpting tools. Let's make this a little bit bigger. So we want to enter the sculpting view. Here's our mesh ready for sculpting. Oh, I don't know what that is. Oh, we're symmetrical. I do not need symmetrical. How do I disable that? See, we got it mirrored. Symmetry, mirror, none. All right, so now we've got our clay strips layer, our sculpting tools. We just want to see, I'm not a sculptor, I don't know what's going on here necessarily, but let's just for the sake of it say, let's make some clay here. How do I go down? All right, so we want the terrain to look a little down as we get to the water because, whatever, get down to sea level. Let's say the campfire is up on a bit of a hill since it's going to have rocks around it, so we want it to be up. And let's just also say that we need, maybe not that. How do I do just like a random? I would like it to be a little bit random. So let's go Blender, Sculpt, Random. Add a branding noise to a Blender Sculpt. All right, so maybe now that we have sort of a basic thing, just for the sake of getting this ready to go, let's go back to modeling. Let's add a modifier and let's see what we've got. We want to deform it. So let's try adding displacement to it. And I don't know how to get it to appear displaced. It's a placement against a texture. New, what have I done? I've displaced everything down into the ground here, so something's a little wrong there. We'll get rid of that. Let's do Blender displacement random. So this is for using a displacement map. I just want to have a random displacement picture. So let's see what else we can do for displacement. Don't want to simulate. We want to add some displacement to it, but I think we need to do a new texture. And let's go to texture paint mode. And if I edit our texture, I want to select this guy's modifiers to displacement. How do I open browse image? That's not what I want. I want texture editing. I'm no expert at Blender. You know what? Let's just leave it at this. This is good enough for now. Let's say I wanted this model, so I think I need to go File. First, let's get rid of this camera. We don't need that. This light, we don't need that. We just want a basic mesh. All right, so File, Export. Let's do export Blender, export mesh Godot. This is some more technical artist stuff, which would be better suited to a specific topic. There's plenty of stuff to read from this, but I'm just going to quickly look up how to import an asset. Let's see if we can file export as a collada, which is the default. I think that's supported. And we'll just go to our repository, so LD46, project test scenes, and we'll just call it untitled because it's not going to be very useful for now. Right. So now that we have our new untitled collada, I want to go to our level, and instead of using this basic mesh, I want to load our, where is it? Oh, that's right. It's not worked that way. You add it here directly. In here, we'll make a new inherited scene. It has this plane. So here's our plane from Blender. It's not very good. Resolution's pretty low. But the important part is that we're going to create the navigation mesh based on that. And just for the sake of it, oh, it must be a grandchild navigation mode. We'll put it up a little bit. Okay. We'll save this as just untitled, that scene. And that is because when we come back to this, instead of using the level, we'll just add this untitled scene. We'll delete this level. Delete. So now instead of having two of them, I don't know why we have so many of them. I must have added a second one on accident. We've got this navigation object here. If we step into it, open anyway. Oh, it doesn't have it. Let's go back to this. Let's do editable children, and for this plane, create navigation mesh, and raise that navigation mesh just a little. Right. So now when we run this, our character is sitting on here, and the navigation's a little messed up. Once again, this is a problem of probably the way that I exported the image from Blender, or the mesh from Blender. But we can see we have a character, and it's moving along, and it's walking around stuff. So there's going to be a lot of adjustments in place to make sure that this all fits. You know, how far out is the camera? What do these objects look like? What is the resolution of our mesh? We can see it's very simple. What we'd probably rather do is create a much simpler mesh instead of having a whole bunch of vertices on it. Instead, we would simplify it, which is probably something Blender can handle, and then we'd have our character walk around on that in a way that plays nicer with Godot. But for now, we've kind of just went over the way that the navigation mesh tutorial works, but it gives us a good starting point to say, hey, this is how our character is going to move around. Once you add some animations, some lighting, some fancier models, you're going to wind up with something that looks quite nice by the end of it. But as of now, the objective that we had when we started into this was, hey, we took a look at our GameStorming. We wanted something like this with a player that can walk around. We now have a player that can walk around in our own game. We wrote the script ourselves, so we understand it better, so we can modify it to suit our needs. And then we can start adding in the things that we need for our game and tweak it from there. So with that, I think that's all I'm going to be streaming tonight. I'll probably continue on this and clean it up a bit and maybe get prepared for the work we're going to do tomorrow. But in general, there's not going to be too much on this. So for the next step, we'll probably be coordinating with everybody else on the team, and then come up with another thing that we want to implement. If it's the player picking up an object, if it's the player walking on the map in a way that's a little more realistic, if it's just kind of working together to build a map that we can mess around with and test out the visuals on. Once we determine what is the next step, we'll kind of do some planning ahead to see how we're going to implement that step. And then finally, we're going to go ahead and implement that ourselves, add to the game, and then rinse and repeat until we have something that we're ready to submit for Ludum Dare. So chances are, once we have the next step that I need to work on, we'll be including that in the stream here. But probably the last thing we're going to do is, because we've made some changes to our project, we're going to go back to our version control, and we're going to stage all of our changes. Now, what file is huge? Oh, you know what? Just as an example of why you don't do things the way that I did, if we look into our test scene, we can see that that mesh that we imported, the mesh that is both terrible and not very useful, it's also gigantic. Same with everything that uses that mesh is also gigantic. So we wouldn't want to commit this mesh necessarily. For now, it is only 2 megabytes, and our project's ultimately not going to be enormous. But we're going to do ourselves a favor and say, hey, these mesh properties, um, I don't think I really care about having it. So I'm going to move it to LFS. Once again, that's just a Git thing. Um, import is fine. Title is fine. Navigation is fine. MD5s and the project itself. I'm going to stage these changes. I'm going to commit them to my feature branch so that way I don't lose my work. File status, commit, adding initial navigation mesh for player. And I'm going to push those to the repository. And that means that we've worked on this step. So this navigation itself isn't fully complete. I might do a little bit more before I merge it in with master, but now it's in a place where everybody else I'm collaborating with can take this feature, test it out themselves, merge it into master if we needed to, or we can start basing changes on my work. So that way the final the final mesh will be more than just the work that I do. Or sorry, the final mesh navigation will be more than the work I do. So with that, though, I'm able to collaborate. Everything's on GitHub. I don't have to worry about losing my work. And with that, I think we're done with that step. So thanks for tuning in. Hopefully you're okay with watching this for 2 hours. Very long. But this is kind of just a part of the process of going through what we're going to do with the game jam. So hopefully it'll go a little bit faster moving forward. Navigation mesh is something that's brand new to me. So I was learning this just along with anybody else who's not used to it. So there's a lot of learning in these game jams, which is really good. So with that, thanks for watching.